Welcome back, dear students and friends.
In this module, I am going to discuss three important concepts: classes and objects, classes and functions, and classes and methods. Here, in today's session, I am going to discuss classes and objects. Let's start with the session. Object-oriented programming uses programmer-defined types to organize both code and data. So, dear students, class is a concept that is there in object-oriented programming. Here, any object-oriented programming uses a programmer-defined types that will going to organize both code and data. Whereas in case of procedure-oriented languages, the code will be kept separate and data will be separate. In case of object-oriented programming language, code and data both will be bundled together, and that bundle will be called as a object. A class is a code template for creating objects. Objects have member variables and have behavior associated with them. Means any objects which contains data and the functions, that function we call it as a behavior. Class can be created using a keyword called class. Class creates a user-defined data structure which holds its own data members and member functions. Every class is going to have some data members, which you can consider as variables, and the functions which work on those variables. The data members and member functions can be accessed and used by creating an instance of that class. A class is like a blueprint for an object. Even the instance of class is nothing but object itself. The data members and the member functions of a class can be accessed by using a object. By creating an object, we can access the data members and even the member functions. In Python, a class is created by keyword class. An object created using a constructor of the class. Constructor basically it is a method of a class which has got the same name as that of a class, and whenever we are going to create an object, by default that function will be called and it will execute automatically. Such a function which is called by creating an object is called constructor of the class. We have used many Python's built-in types, but in today's session we are going to define a new type, our own data type, which are called as user-defined data types. As an example, we will create a type called point that represents a point in two-dimensional space. Like if we consider int, float, these are built-in data types. But what we do now, we are going to create our own data type which is going to create a point. In mathematical notation, points are often written in parentheses with comma separating coordinates. Like for example, 0, 0 represent origin, and in general x, y represents the point. X units right to the origin and y units up from the origin. Right? And in case of Python, there are several ways to represent a point. Basically, three ways are there. In the first way, we could store a coordinates separately in two variables x and y. So the variables means the coordinates of x and y. To store them, we are going to use a separate two variables. And in second method, we could store the coordinates as elements of a list or tuple. Storing points means coordinates, we can use either tuple or even the list. And in third method, we could create a new type to represent points as objects. So now we are going to see this type on this third method only, because first two you can do. But here this session will concentrate on creating new data type. A programmer defined type is also called a class. As I was telling, class is nothing but a programmer defined type. A class definition looks something like this. So here there is a keyword called class, and this is whatever the point you can see, it's a name of the class. So you can have any name of the class, and remember by default, we are going to assume while giving the name to a class, the first character will be taken capital letters and remaining characters will be small letters. So this is a definition. Class, this is class name. So letter colon, and here this is indented doc string which is going to tell what type of class is this. Okay, the header indicates that say new class called a point, means this is a new class whose name is point. The body is a doc string that explains what the class is for, means for what purpose this class is created. It will going to tell that this is going to represent a point in two-dimensional space. We can define a variables and methods inside the class definition. Okay, once the class is created, we can have the variables and methods. Remember, methods are nothing but functions which will work on the variables of the class. Defining a class named a point creates a class object. Like say if I type a point, it is going to tell so this is a class object. Because point is defined at the top level, the full name. So this will be the full name. So whatever the point, the class variable will be there, its name will be something like this. Before we proceed further, let me show you a simple example to create a class. I am going to use Python 3 interpreter. Python 3 interpreter can be called by executing a command Python 3 on Linux terminal. Right? Say here, I am going to create a class called point. Class is a keyword. Say point, and this is colon. And here in indentation, I am going to write some doc string represents a point in 2D, two-dimensional space, and this is the end of the class. So now if I write just a point, so this is what we get. What type of object is this? It's a class object, right? A class is like a factory for creating objects. To create a point, we call point as if it's a function. Like say for example, if at all I want to create a object, you can consider a class as some template, and using that template we can create any number of objects. Means we can consider a class as a factory of creating objects. Any object can be created just by using a name of that class. So because as I told, constructor is a method whose name is similar to that of a class name. And when we call that constructor, say it will going to create a new object of type class. Say here I have already created a class called point, and if at all I want to create a one object out of this, I can create a one object called a blank, means something like a blank point. Blank is equal to say point. Now if I type just blank, so what we get is it's a main point object, means this is an object. Remember, point is a class, whereas just now I have created a blank variable which is nothing but a object, and here it is displaying where this object is stored in a main memory. 0x indicates it's a hexadecimal, means the address is given in hexadecimal form. The return value is a reference to a point object which we assign to blank. Creating a new object is called instantiation, and the object is a instance of the class. When we print an instance, Python tells us what class it belongs to and where it is stored in memory. Here it has told this it belongs to a point. Point object is nothing but, so this is the name of the class. It belongs to a point class and it's stored in this memory, right? So every object is an instance of some class. So object and instance are interchangeable. That's what. So sometimes we call object as an instance or instance as object. Both can be interchangeable because both refers to the same. Once we create class, we can have any number of objects which are called attributes of the class. We can assign values to instance using dot notation, because blank is just a instance or object. To that object we can assign some value. Here, because point class point is going to represent a 2D point, so there should be two variables which will represent two coordinates of a point, namely x and y. For that purpose, we can create two variables with respect to that class, like by writing blank dot x is equal to 3.0 and blank dot y is equal to 4.0. So this syntax is very much similar to the syntax for selecting a variable from a module, such as we have selected math.py or string.whitespace. So means we are going to use the variables whitespace or py from these particular modules. In the same thing, you can consider a blank as a module, and x and y are variables in that. In this case, though we are assigning values to named elements of an object, these elements are called attributes. Okay, so x and y are called attributes of a class. The following diagram shows the result of these assignments. A state diagram that shows an object and its attributes is called an object diagram. So this below is an object diagram. So what it is going to show is, it will show the object and its attributes, including the values of those attributes. Okay, so blank is an object. It's of type class point, and it has two attributes, x and y, and x has got value 3.0 and y has got value 4.0. The variable blank refers to point object, which contains two attributes. Each attribute refers to floating point numbers. Right? So here we can read the value of any attribute by using the same syntax of dot operator. So like blank dot y is going to give its value, and blank dot x is going to give the value of this. Before proceed further, I will show this creation of attributes. So already we have point class. I am going to create a attributes called blank dot x is equal to 3.0, and one more is blank dot y is equal to 4.0. So now if I call blank dot x, if I write blank dot x, what I get is, look at this, 3.0, and y it is 4.0. If I write just x, it's nothing, means this name is not defined, because x is different and blank dot x is different. We can assign the variable to any other variable, like x is equal to blank dot x, and if I call x, this is 3.0. But remember, blank dot x and x both are different. Blank dot x is a object variable, whereas x is a normal variable. The meaning of the expression blank dot x means go to the object blank and get the value of x. In the example, we assigned that value to a variable named x. Here we assigned blank dot x value to a variable called x. Remember, there is no conflict between variable x and attribute x, because x is a variable, normal variable, whereas blank dot x is an attribute, which is nothing but a object variable. We can use a dot notation as a part of any expression. For example, say if at all I want to print the point, I can use something like %g. For printing integer, we can use either %g or %d. Say here %g, %g, % of blank dot x, blank dot y. So which will going to represent, this is a notation of a tuple and this is like a tuple. Means it's a point. The same thing we can see in a terminal. Here, if at all I want to print, we can print the %g or %d, whatever you use, %g, %g, right? And here % of blank dot x, blank dot y. So now you can see 3, 4, right? We can use dot notation, so that we have used, and using this even we can find a distance. Here look at this, when a point is given, say if at all we want to find the distance between two coordinates, so that can be calculated something like this: math dot square root of x square plus y square, means under square root x square plus y square, distance is equal to under square root x square plus y square. So that can be done here. Let us find the distance between two points. Distance is equal to math dot sqrt. So this sqrt is nothing but method of a math module, means mathematics module. So inside this blank dot x, say it should be squared. For squaring we use double star square plus blank dot y square, right? So now if I execute this, surely we will get a error because it cannot find a method sqrt. So you can see name math is not defined because we have not imported it. Let's import it, and now you execute this statement. There is no error. If I find the distance, because blank dot x is 3, blank dot y is 4, 3 square is 9 and 4 square is 16, 9 plus 16 is 25, under square root 25 is 5, we should get distance is equal to, yes, it is 5.0. Means here we have accessed attributes using dot notation. We can pass an instance, nothing but an object, as an argument in the usual way. Means however we pass any variable, in the same way we can pass even a object or instance of an class. For example, here there is a one function which defines a print point. It's a function to print a point object where it is going to accept a object of type point. Here p, say print %g, %g and px, py. Here one should note that when we pass any point, like here print underscore point blank, blank is a object of type point, and so when we pass this to a function, what will happen? There it creates an alias to a blank, means this p is an alias to this blank. Print point takes a point as an argument and displays its mathematical notation, that is x, y. To invoke it, we can pass a blank as an argument. Here the blank object has been passed as an argument, and the result of this method is 3, 4. Inside the function, p is an alias for blank itself. So if a function modifies p, that is going to change the blank. So let us create this function. So I will define a method called print point. It will going to take object. So let me use the name of that object as p, and now print %d, %d, % of p dot x, p dot y. So this is a function that will going to print a point. Now to call that, print underscore point, and I am going to pass blank object. Now you can see 3, 4, and here say this p is going to set alias to this blank object. If I going to change something here, that will be reflected here. Say for example, if I write the same thing, and while printing, so let me print it by changing the value p dot x plus 5, p dot y plus 5, right? Now let us first see a blank dot x and blank dot y. Both attributes are 3 and 4. Now if I pass a blank object to a method print underscore point, so here I am going to pass blank object. It has just printed 8, 9, whereas the blank x and y have not changed because I have not modified anything there. But if at all we want to modify, let us consider the same thing, same function I use, same method, and here so let me modify p dot x is equal to p dot x plus of 5, and similarly p dot y plus is equal to 5, and later I can print both x and y, right? So this is to print, and this is the end of the method. Remember, the method name is print function. It will going to accept an object, and that object which we pass is a point object. It has got two attributes whose value will be incremented by 5 units, here 5 and here 5, and later it will be printed. And let us see what is the effect of this on a blank object. So if I call now the method print underscore point blank, look at this, it is 8, 9. So but earlier when I print blank, it was same earlier value, but if I print now the blank dot x, look at this, it is 8 and y is 9. Means here whatever the changes been done in this function, that has affected on the blank variables. Nothing but it indicates that the p is going to create an alias to blank object, right? As an exercise, what you can do, you write a function called a distance between points that takes 2 points as arguments and returns the distance between them. Okay, so write this function and relevant code to call the function. So if any difficulties in writing this function, you can ask me. So with this, we'll move on to say one more class called a rectangle. Let's see here. Sometimes it is obvious that what the attributes of an object should be. Means what should be the type of attributes an object should have. Like in case of point, say we just decided that the object, the point attributes will be like, say, consider floating point numbers. But in some other times, say it will be very tough to make decisions. For example, imagine we are designing a class to represent rectangles. Now here, what attributes would we use to specify the location and size of a rectangle? Means in a two-dimensional space where the rectangle should be placed. If we ignore angle to keep the things simple, assume that the rectangle is either vertical or horizontal, then there are at least two possibilities. In one possibility, we could specify one corner of the rectangle, because in two-dimensional space, if at all I want to represent, in case of the two-dimensional space, if at all I want to represent somewhere a rectangle, say what we can do is, one thing is we can specify one corner of the rectangle or even the center, and along with this, the width and height of the rectangle. So in case of two-dimensional, if we know the corner, from the corner how much is width and how much is height, or from the center where the rectangle is placed. That's one method. And another method is we could specify two opposing corner. Means if we know the two opposing corner, say then by joining that we can construct a rectangle. What we do at this point, even it is hard to say which method is better. So, we'll just ignore it now. So what we do, we are going to implement the first method. In the first method, to specify any rectangle, we are going to use one corner point and width and height of the rectangle. So let us see how it can be done. Here is a class definition. Class rectangle, this is the name of the class, followed by colon, and this is a doc string which will tell that, so that this is going to represent a rectangle having attributes width, height and corner. Okay. Here, to represent a rectangle, we have to instantiate a rectangle object. Means we need to create a rectangle object and assign a values to the attributes. These three are the attributes. Let's assign some value. First, object instantiation can be done by calling a rectangle function. This is a rectangle function. So when we call this function, by default a object is created, and the name of the object here is box.width some value and box.height some value. There are three attributes, width, height and one more is corner. So because this corner is a point, what I do here, box.corner is equal to point. Remember, so this corner is an attribute of a class rectangle. Even say this attribute is, once again, means this particular attribute is an object. Because if you see, I am initializing this box.corner is equal to point. Means point is once again an object. Here it will going to instantiate one object. So here box.width is a plain variable. Only thing is it's a variable in a rectangle class. Whereas this is object in a rectangle class. Okay. And this box.corner x, look at this. If at all I want to initialize corner, I need two variables. This point has got two attributes. One attribute is x and another attribute is y. To represent them, say what we do, we'll go to box.corner, means this is a box rectangle. You can see this is a box rectangle. It has got two attributes. One is width and another one is height. And another, say third one is a corner. This corner is again an object which represent to a point class. And it has two attributes x and y, say which have been initialized to 0. So one thing you should note here that to access this x and y, we have used twice dot operator. Once x dot corner, which will going to access this corner, and from this dot x, it will going to access this point. Similarly, say this is box dot corner dot y. Okay. So the expression box.corner.x means go to the object box and select the attribute named corner, then go to that object and select the attribute named x. Okay, so figure above shows the state of this object, means a state diagram of this object. An object that is an attribute of another object. Remember, an object that is an attribute of another object is called embedded object. Means here, so this corner is an embedded object. Okay, so before I proceed further, so let us define this class. So here class rectangle. I am executing all in Python interpreter. Even you can write the say Python script and execute. Represents a rectangle. Its attributes are, one is width, another one is height, and the third one is corner. Right. So now I am going to create a box rectangle. I am going to instantiate a rectangle. Right. So let me assign a values to the attributes of this rectangle. Box dot width is equal to width, let me take it as a 100.0, and box dot height is equal to like 200.0. Width is 100 and height is 200. And similarly box dot corner is equal to s. Say it is a point object. And now we need to initialize the point object. So it can be accessed by using box dot corner dot x is equal to I'll represent at the origin, and similarly box dot corner dot y is equal to 0.0. Yes, we have instantiated a rectangle object and initialized all three attributes. So three attributes are, one is width, another one is height, and the third one is corner. Because corner is once again an object, so we have instantiated the attributes of that object. Now continuing, look at this. Functions can return instances, means the way the function is going to accept instances, nothing but objects. Even functions can return instances, means they can return objects. For example, so consider a function called find center, which takes a rectangle as an argument and returns a point that contains the coordinates of the center of that rectangle. Means let us write one function whose name is find center. It will going to accept a rectangle and find the center of that rectangle, where that center means rectangle center will be there. The coordinates it will going to return, means coordinate, the points of that coordinate it will return. It's nothing but a point object it will going to return. So how can we define? So define find underscore center. This is the name of the function which accepts a rectangle object. So rect is the name of that object. Okay, colon p is equal to point. Here one variable is created, means object is created of type of point class. Now we need to find the corner of the rectangle. Remember, the rectangle object which we have considered has got three attributes: one corner point, another width, and another height. So by using a corner, we can go to the corner of that rectangle, and later by adding half of width and half of height, we'll get the center of that rectangle. That's the method we have used here. P dot x means this point x attribute I am initializing is equal to rect dot corner dot x, means that corner point plus half of the width, and similarly y coordinate of that corner point and half of the height. It will going to give a center which is represented by p dot x comma p dot y. So that point will be returned. Return p will going to return that point. And if we pass that particular, means here is an example that passes box as an argument and assigns a result point to a center. Means here center is equal to find underscore center box. We are going to create a box, and already we had created a box, and if we pass this as a argument to this function, it will going to return an object called point, say which has got values 50 and 100. So we'll execute this and see the result. Already here we have created a box object. You can see box.width and another one is box.height, right? And corner points are box.corner.x and box.corner.y. Means the meaning here is this particular box is exactly at the origin. So from the origin it is there in a first quadrant. Obviously the center will be half of this and half of this, right? So let us see this. We are going to define a function called find center, find underscore center, which will accept a rectangle object. And now here I am going to create a point called P. It's a point object. P is a point object. And P dot x is equal to, it's a rect dot corner dot x plus half, it is a width by 2. Means width can be accessed by rect dot width by 2. So similarly P dot y is equal to now rect dot corner plus y plus of rect dot height by 2, and later return is P. This is the end of the function. So now we can call this function and store the return object in an object called center. Center is equal to find underscore center, and here I'll pass box object. Already these are the attribute of box. Width is 100 and height is 200. The center we should get is 50 and 100 because this particular rectangle is at the origin. So let us see. I'll call like this. Center is equal to find center, and there is a function called a print point, right? So I'll use that function and I'll supply the center as an argument. It will going to print the coordinates of that. So it is 55 plus 105. Why it is 55 plus 105? Okay, say we had the point object. Already see the point object box. What's the point? Box dot width is 100, right? And box dot height is, what about corner? Box dot corner dot x is 0 and even y is 0. But remember, so when we wrote a print point function, there we added explicitly, we added plus 5 to that. Here you can see define print point, we added explicitly plus 5 to that. Because of that, instead of getting 50 and 100, we are getting 55 and 105. I hope you understood this. As per this, we should get 50 and 100. But here while printing, just to tell that the alias is going to change the object. I have added 5 to x and 5 to y. Because of that, 50 plus 5 you are getting 55 and 100 plus 5, so you are getting 105. Hope this is clear to all of you. Right. So objects are mutable. Means we can change the attributes of the objects. We can change the state of an object by making an assignment to one of its attributes. For example, to change the size of a rectangle without changing its position, we can modify the values of width and height. Like something like this. Box.width is equal to box.width plus 50. So which will going to modify the width of a box. Similarly, box.height is equal to box.height plus 50, which will going to modify the height of the box. Okay. So we can also write functions that modify the object. Means we can explicitly modify the attributes of object. Otherwise, we can write functions which will modify the attributes of the object. Nothing but modifying the object itself. For example, there is let us consider a function called grow rectangle, which takes a rectangle object and two numbers, d width and d height, and adds the numbers to the width and height of the rectangle. Means it is something like a given a rectangle, it will go, the rectangle will grow by this much of width and this much of height. That's the meaning. Say here the simple function is there, define grow rectangle. Say it will going to take a rectangle object and two numbers, means this rectangle is going to grow by this much width and this much height. It's very simple. Already whatever the width is there, to that width you add this width, incremental width, and to existing height you add this incremental height. It's a simple thing. And later if we print the rectangle, obviously so the rectangle will be grown by say this much width and this much height. So before we proceed further, let us execute this and see the result. Okay, so already let us see what are the values of box dot width. Yes, box dot width is 100 and box dot height is 200. So let me write a function called grow underscore rectangle. So this function is going to take 3 arguments. One is rectangle and another one is d width and another one is d height, right? Now here rect dot width is equal to, so I'll directly use a short notation, plus is equal to d width, and rect dot height plus is equal to d height, right? So now if I call this function here grow and I'll pass the box rectangle to this. Remember, before calling this, the box width is 100 and box height is 200, and now I am calling grow rectangle. Okay, sorry, this grow rectangle is going to take 3 arguments. I have specified only one. So the box, it has got width 100 and height 200. So let me increase width by 10 and height by say 20. Okay, let us see this. Oh sorry, here once again, so I wrote this spelling mistake, so I'll just make it fast. This is the function name and this is rect dot width is plus is equal to, and later this is rect, right? And this is the end of this, end of function definition, and grow rectangle. And now if I print box dot width, look at this, this is 120, box dot height, it will be 220. Okay, because earlier, say once again, say earlier this has executed, because of that it has added already 10. So let us call once again. So right now the box width is 120 and box height is 220, and once again I call grow rectangle by 10 and 20. Box width should become 130 and height should become 240. Okay, let us see this. 240 is height, 130 is width. Hope this is clear to all of you. Any function can return instance of a class, nothing but it can return a object. Okay, here we called it, so we have seen this. Inside a function, rect is an alias to a box. So when a function modifies rect, the box changes. As an exercise, write a function named move rectangle. So just now we discussed a function called grow rectangle, but you people can write a function whose name is move rectangle that takes a rectangle and 2 numbers, namely dx and dy. What it does is, it should change location of rectangle by adding dx to x coordinate of the corner and adding dy to y coordinate of the corner. Means earlier function which I had written, it grown the rectangle, but the function that you are going to write here, it should move the rectangle. Means if the rectangle is from the origin, move rectangle, it should take a rectangle and 2 numbers. It should move the rectangle using that. Means x should change to x plus dx and y should change to y plus dy. Write this function. So if you get any difficulties, you can ask me. With this, we'll move on to copying a object. How do we copy existing object? Remember one thing, aliasing can make a program difficult to read because changes in one place might have unexpected effects on another place. So even this we discussed earlier also. Whenever we create aliasing, because of a more number of aliases, it is hard to keep track of where the object is changing. For that purpose, what we normally do is, if the change is unnecessary, we can create a copy of that object and modify that object or work on that object. Okay, so as I told, it is hard to keep track of all variables that might refer to a given object because of a many number of aliases. Copying an object is often an alternative to aliasing. But remember, the copy module, there is a module called copy. The copy module contains a function called copy that can duplicate any object. So like say for example, p1 is equal to point, it will going to create a point, and let me say initialize that p1.x is equal to 3.0 and p1.y is equal to 4.0. To use a copy function, we should import the module copy. Say import copy, later p2 is equal to copy.copy of p1. Means this is a function, it is there in this module. Copy.copy p1 means it will going to copy p1 to a p2. And so this is what p1 and p2 contains same data. When after the copying, p1 and p2 contains same data. Print p1 3 and 4, print p2 3 and 4. We will execute this and see. Say p1 is equal to point. Let me see p1.x what we have. Nothing. Say I'll create p1.x is equal to say 3.0 and p1.y is equal to 4.0. Right. Say I have created a point, and if I print it, p1.x is 3.0 and p1.y is 4.0. Now I want to copy this object, a point object p1. For that purpose, import copy, right? p2 is equal to copy.copy p1. Means it should copy p1 to p2. Means say p2's attributes should be same as that of p1. Now if I print p2.x and p2.y, same thing. Remember, p1 and p2 both have same data. But if at all I am going to type p1 is p2, what we expect? We expect false, because p1 and p2 both are different objects. Both might be having same data, but both are different objects. Because both have same data, what we expect? p1 is equal to p2. What we expect? Whether true or false. Say as p1 and p2 contains the same data, you may expect that p1 and p2 both are same. Means both are equivalent. Means you may expect true here, but it will be false. Because here, say even though p1 and p2 it will going to see the equivalence, but what kind of equivalence it will see, that has not been defined in that class. Because of that, say it will going to treat equality as is operator itself. Because of that, it will going to return false here, right? The is operator indicates that p1 and p2 are not same object, which is what we expected. Okay, because it returned false. So but we expect this to yield true because these points contain the same data. In that case, even we didn't get a true, because the default behavior of say equality operator is the same as that of is operator. It checks object identity, not object equivalence. That's because the programmer defined the types. We have not defined, say in a class, how the equality operator should be treated. Python doesn't know what should be considered as a equivalent in that particular class, right? If we use copy to duplicate rectangle, so we'll find that it copies the rectangle object but not the embedded point. So here, so if you see, we have created a box called rectangle, which was pointing, the box has got 3 attributes, as we know, one width, one height, and another one corner. And corner is nothing but a point object which has got 2 attributes x and y. So what we do, we are going to copy the box and let's see what is the impact. And when we created a point, when we copied of one point to another point, point p2 has the same data that of a point p1. Let us copy a rectangle object and see what is the effect. Let me initialize that. Box.width, it is 130, but I will initialize to once again to 100. And box.height, so let me initialize this to some 200, and corner points box dot corner dot x is equal to, say, let me make it 0, corner dot y, say, is 0. So this is a box which I have created, right? Width is 100, height is 200, and corner point is at 0, 0. Now let me create a box called box 2, which is equal to copy dot copy of box. So now if I type box 2 is box, obviously we will expect false. And if I type box 2 dot corner is box dot corner true. Remember, box has got 3 attributes: width, height and corner. Box 2 is box, it's false, means box 2 and box both are different, both are 2 objects. Whereas box 2 dot corner is equivalent to box dot corner. This is true. Means corner is what? It is a point object. That point object is same, it has not been created. That's the meaning. It's the same thing. Here say box has been created, means box 2, box both are different. Whereas box 2 corner and box corner both are same. It has not copied that. Say the meaning here is, the meaning of this is, if we look at the object diagram, here, so this is a box which has got 100 and 200, and we copied this to box 2, which will be 100 and 200 only. Whereas the corner here, it is pointing to one object, x and y, point object, and even this box is pointing to the same object x and y. Because of that, when we printed box 2 dot corner is box dot corner, we are getting true. Box 2 dot corner is box dot corner, that is true because this is the same object. What's the meaning? Remember, copy has created one more box, but it has not created all the attributes, means it has not created all the attributes, only width and height it has created, and this corner it is pointing to the same old object. So the figure shows what the object diagram looks like. This operation is called shallow copy because it has not copied all the attributes. Shallow copy because it copies object and any references it contains, but not the embedded object. As I told, the corner point here is an embedded object, so it has copied the other attributes but not the embedded attributes. Okay, because of that, this copy we call it as a shallow copy. Say that's what even we have seen in this here. Okay, say box 2 is false, box 2 is box is false, whereas box 2 corner is box corner. Box 2 dot width will be same as that of box width. It has copied it, and box 2 dot height will be same as that of box dot height. It has copied and created 2 values, whereas it has not copied the corner point. It's the same point. Because of that, here we are getting, when we applied box 2 dot corner is box dot corner, we are getting true, right? Now for most of applications, this is not what we want. Means when we want to create a copy, it should create everything. It should copy everything, even including embedded objects. Here in this example, invoking a grow rectangle on one of the rectangles would not affect the other, but invoking move rectangle on the either would affect both. So this behavior is confusing. So remember one thing. So after copying this, when we invoke a grow rectangle on one rectangle, it will not affect the other because grow rectangle is going to add width to width and height to height. Means whatever that number is, it will be added to width and height. Because width and height will be separate for both the objects, it will not affect it. Whereas move rectangle, say there we are going to change the corner point. Because the corner point will be changed, the move rectangle and the corner point is same to both the rectangles. Because of that, a move rectangle is going to affect both the rectangles. I hope whatever I have explained here is clear to all of you. So this is very important concept of what I have explained. Okay. Fortunately, the copy module provides one more method called a deep copy that copies not only the object but also objects it refers to, and the objects they refer to, and so on. Means say it will going to copy all the objects, it will going to refer in turn, it will refers to some other object, everything it will going to copy. So this operation, that's what this operation is called called as a deep copy. Like if I create box 3 which is equal to copy dot deep copy of box, then box 3 is box, obviously it is false, and not only that, box 3 dot corner is box dot corner will be false. Remember earlier when we applied box 2 dot corner is box dot corner, we got true, but now when we apply box 3 dot corner is box dot corner, because of this deep copy it will going to create even a different object for corner point also. So let us execute this in terminal, right? So already we have a box dot width which is 100, then box dot height which is 200, and one more is box 2 dot height is 200 and box 2 dot width is 100. Okay, so now what I do, I am going to create a new object called box 3 is equal to copy dot, here I am going to use deep copy of box, right? Now box 2 dot corner is box dot corner will going to give true, whereas box 3 dot corner is box corner is false, because a deep copy will going to create a corner point also, it will going to copy the corner point also, whereas copy will not copy the corner points. I hope this is clear to all of you. As an exercise, you write a version of move rectangle that creates and returns a rectangle instead of modifying the old one. So try to write this exercise program along with the functions to move the rectangle, and if you face any difficulties you can ask me, right? So this is what I wanted to discuss in this session about classes and objects. Okay, if you come across any doubts and difficulties, feel free to ask.
Hope this is clear to all of you, dear students. Thank you. Thank you for watching.